Welcome to the deep dive. We are tackling a hyper-accelerated release today, one that didn't just move the goalposts.
No, no,
It feels like it rebuilt the entire field in, what, the space of 3 weeks?
that's about right. It was incredibly fast.
So our mission today is to really unpack the technical advancements that drove this, well, this emergency top-tier rollout of GPT 5.2. We're going to look specifically at the core architectural changes.
And we have to dissect the benchmarks, the quantifiable wins that, reestablish their market leadership.
Exactly. And then we'll analyze the immediate and I think pressing economic implications for enterprise users, for developers, basically for anyone who now has to plan around a velocity that's measured in days, not months.
And it's absolutely crucial to start with the context here. I mean, the context dictates everything. The pace, the technical choices they made. The source material is unequivocal on this.
Right.
This was not a standard planned update. The GPT 5.2 release on December 11, 2025 was a direct internal mobilization. They called it a code red response.
A code red. That's a term you usually reserve for catastrophic failures, right?
Yeah.
Not for product launches.
Precisely. And this high-stakes urgency, it was triggered by competitive pressure that landed just a month before, in November 2025.
Google's Gemini 3.
Google's Gemini 3 model. The report said Gemini 3 took a momentary lead in several really critical areas. We're talking multimodal reasoning, complex logical consistency, and just raw efficiency and API speed.
So OpenAI, in essence, couldn't afford to be seen as number 2, even for a few weeks.
They couldn't. This was an existential race for the state of the art.
And the competitive velocity here is, it's just staggering. For our listeners who are out there planning their integration roadmaps, this is the number that should really stick with you. GPT-5 was the flagship model back in August.
Just August.
Then GPT 5.1 came out in November.
Yeah.
And now, less than a month later, we have 5.2.
And the internal estimates suggest this release was accelerated by, at least a few weeks?
At least. It was rushed out to meet that competitive crisis. And it just goes to show that market leadership now, it's measured in weekly iterations.
That speed, it fundamentally changes the whole dynamic of enterprise integration. If you're a CTO, you just can't assume that a model you deploy today is going to be the strategically optimal choice in 6 months. It's not even close.
Right.
And the sources, they even indicate that GPT 5.1 is officially deprecated just 3 months after 5.2's launch.
3 months.
That kind of a short lifespan imposes significant infrastructure instability. Developers are now forced to operate under this mandate of continuous evaluation and dynamic model routing.
Just to keep up.
Just to ensure their applications are even using the state-of-the-art.
Right.
And that is a new and a very costly burden.
So it's a new reality. The cost of migration is now just baked into the quarterly budget, whether a new model is announced or not. You have to assume it's coming.
You have to.
Okay, let's unpack this. Let's get into the nuts and bolts of how OpenAI executed this competitive counterpunch so quickly and, so effectively.
Right.
And that takes us to our first major area, the core technical leap, which is this shift to the mega agent architecture.
Yeah, and this is the key, the primary performance leap in GPT 5.2. And really the reason they could accelerate the release schedule, it's all attributed to a fundamental architectural shift.
Okay.
They basically targeted the internal friction points that had, accumulated over generations of adding more and more specialized capabilities.
So let's define that. Before 5.2, what did one of these complex, multi-layered systems even look like? What was the fragility there?
So imagine the model gets a query. Previously, the system often relied on this really complex externalized routing structure. You can almost think of it as a small, specialized model layer that's just dedicated to flow control.
A traffic cop, basically.
A traffic cop, exactly.
Yeah.
And this router had to decide, okay, does this query need scientific analysis or code generation or maybe visual processing? And it would then route the signal to the right internal module.
And the industry feedback described this as a fragile, multi-agent system.
It was fragile because the friction created by that internal decision tree, the routing overhead, the signaling latency, the potential for just picking the wrong module, it slowed things down and it introduced variance.
So if that traffic cop made a wrong turn and sent a visual task to the pure reasoning module, the output quality would just tank immediately.
Immediately. So the shift in GPT 5.2 was collapsing this entire specialized infrastructure. They moved from that fragmented approach into what they call a single mega agent with 20+ tools.
A single mega agent.
It's one monolithic, unified transformer entity that just inherently possesses the capabilities of reasoning, vision, and code execution, all of it, but without the overhead of that external or layered internal routing.
That sounds like a massive engineering undertaking. It feels like a good time to run a neural signal check.
Yeah.
Here's why this development actually matters at a technical level. I mean, if they're using roughly the same number of parameters, how does just unifying it grant such a huge efficiency gain?
It's all about streamlining the forward pass. By unifying these functions, they essentially eliminate three critical friction points at the same time.
Okay, what are they?
First, the reduction in latency is dramatic. You just get rid of the time spent on internal orchestration and module selection. It's just gone. Second, the developer reports on this are huge. They claim this mega agent is 100x easier to maintain.
100 times easier.
Think about that from a technical debt perspective. That reduction means they can iterate faster for the next update.
Which, given the competitive landscape we just talked about, is maybe the most important win of all.
It could be. Precisely. But third, and this is probably most critical for you, the listener, who is building actual applications, it provides much stronger tool calling.
Okay.
The model can now intrinsically manage its suite of 20-plus tools, whether that's generating or complex geometry calculations, all in a single coherent thought process.
So it reduces that variance in output quality that used to plague those complex, multi-step agentic tasks. So the downstream effect for engineers, for you, the developer listening, is this massive simplification. I remember when getting GPT-4 to handle a simple two-step agentic task required, like 50 lines of system prompt, just to manage tool selection and error handling.
Oh, yeah. The prompt engineering was a nightmare.
And if the model can now execute these complex workflows cleanly based on a simple one-line prompt that just accelerates deployment timelines dramatically, you're eliminating the need for these sprawling external agent frameworks that were, basically mandatory before.
And the sources confirm this. It immediately simplified prompt engineering. If you're building an application that needs to analyze a PDF, that's vision, then perform complex calculations, that's reasoning, and then output the results into a structured JSON, that's tool use.
A pretty standard workflow.
A very standard workflow. The Mega Agent handles this so much more smoothly, end to end. Early tester feedback noted they no longer need those sprawling system prompts because 5.2 will execute cleanly off a simple one-line prompt. I mean, that's a paradigm shift in how we build these applications.
It really does sound like a pure technical triumph, but the more powerful and unified the entity, the more concentrated the risk, which leads us to the crucial implication that, the sources don't really explore in their marketing materials.
Yeah.
The consequence of this unification for enterprise safety protocols.
This is a massive trade-off, a huge one. The core technical implication is that concentration of power. You've successfully created a single, highly privileged entity that possesses maximum capability. And while that's efficient,
I mean, they've centralized the risk.
you have.
Wow.
If there is a failure of alignment, or if a successful exploit, say a jailbreak leading to malicious code generation is achieved, that attack will be executed with the full efficiency and comprehensive tool use capability of that single entity.
So just to spell that out, previously a jailbreak might have only successfully compromised, say, the reasoning module, but then it would fail when the external router tried to hand off the task to the vision module. That created friction, a potential detection point.
Exactly. Now, that malicious intent is executed with the seamless end-to-end efficiency of the Mega Agent. If your single agent is deployed with tool calling privileges that let it debug production code, or access databases, or manipulate cloud resources, a successful jailbreak becomes a critical infrastructure threat.
Right.
So this concentration, it mandates elevated levels of input validation, scrubbing the prompt before it even hits the model, and more importantly, real-time output monitoring for enterprise safety protocols. You have to assume the single point of failure is now exquisitely powerful.
I find myself slightly skeptical of that 100x easier to maintain claim, though. Aren't they just trading the headache of maintaining internal routing logic for the headache of ensuring alignment and safety across 20-plus fused capabilities? It feels like a risk shift, not a risk elimination.
It is absolutely a risk shift. That's a great point. The maintenance claim is focused on the software architecture, no longer having to debug complex internal routing or those external agent chains.
Okay, so from a pure engineering standpoint.
Right. The new engineering challenge is, as you point out, the alignment and the monitoring stack. The sheer power of this unified agent forces a more robust, specialized safety architecture outside the model, which is a significant new cost for the enterprise.
You're trading system complexity for safety complexity.
Perfectly put.
That makes the shift from architecture to quantifiable results even more vital. They needed to prove that this massive architectural bet actually paid off in performance metrics that matter to the C-suite.
Yes.
So OpenAI released 5.2 strategically, shifting the focus away from those abstract academic benchmarks toward metrics that quantify return on investment and professional knowledge work.
The competitive response required them to reassert supremacy, and they did it decisively in core symbolic reasoning. The headline win here, the one that got all the press, was the performance on the AFE 2025 competition.
And for our listeners, the AIME, the American Invitational Mathematics Examination, is a notoriously challenging high school math competition. It requires deep, complex, multi-step algebraic and logical manipulation. So what was the score, and why is it so significant?
GPT 5.2 achieved a perfect 100% accuracy on AIME 2025.
Perfect.
A perfect score. And this is the important part, without using external tools. Let's really emphasize that, without external tools part.
Right.
That perfect score is a key measure of the model's fundamental intrinsic logic capability. And to benchmark this competitive win, Gemini 3 Pro scored 95% without tools, and the previous OpenAI state-of-the-art, GPT 5.1, hit 94%. So this 6-point leap to perfection, it just closed the gap entirely.
Okay, let's focus on the engineering implication. Why does this intrinsic 100% logic capability matter? I mean, if I have a tool-labeled model, why shouldn't I just let it use its computational crutch-like running Python code to get the answer right?
Because relying on external tools introduces latency and cost, and more than that, it suggests a weakness in the core reasoning engine. Achieving 100% without external tools means they successfully address these scaling bottlenecks that previously required the model to rely on computationally expensive thought chains or external execution just to ensure numerical accuracy.
So it suggests a denser, more reliable representation of logic and math principles within the model's own internal weights.
It does. For the user, it means faster, more confident, and ultimately less costly outputs on reasoning tasks.
It essentially means the model's brain is just fundamentally more competent at pure math and logic, so it reduces the need for that expensive, time-consuming introspection.
Precisely. And moving beyond abstract math, the real enterprise value here lies in autonomous coding capability. Software engineers are, one of the most expensive resources for any company.
So how did GPT 5.2 perform on the specialized software engineering benchmarks, like SWE-bench?
SWE-bench is a crucial standard. It's so important because it focuses on fixing real, reported GitHub issues. This requires a deep understanding of existing code bases, context awareness, and generating verifiable solutions.
Real-world problems.
Exactly. And on SWE-bench Verified, which is restricted to Python, GPT 5.2 Thinking scored a new OpenAI state-of-the-art of 80%. This is a functional level of performance.
Wait, 80% on fixing real-world GitHub issues?
Yeah.
That's one with autonomous junior developer status.
It translates directly to verifiable professional value. I mean, we are talking about a model that is reliably capable of debugging production code, implementing feature requests autonomously, and refactoring large code bases without significant human intervention.
So this makes it suitable for integration into sophisticated CI/CD pipelines.
For sure. For the non-technical listener, CI/CD continuous integration, continuous deployment is the backbone of modern software development. It automates the testing and deployment process, so injecting an 80% accurate autonomous developer into that pipeline is, well, it's transformative.
And they also showcase the model's depth across different languages with the larger, more challenging benchmark, right?
Yes. On the broader, multilingual, and contamination-resistant SWE-bench Pro, which tests 4 different languages, it scored 55.6%.
Still very impressive.
It confirms its generalized utility beyond just Python. They're positioning the AI not just as a coding assistant, which is what GPT-4o really was, but as an autonomous multilingual developer that's ready to handle complex agentic workflows. And to reinforce this, they still maintain the specialized GPT-5 codex model, which is optimized for command line interface use and those high-throughput coding tasks.
Okay, so now let's look at abstract reasoning. This is always the bellwether for genuine fluid intelligence and novel problem solving in areas like R&D. And the ARC-AGI-2 benchmark is key here, since it tests whether the model can generalize patterns it hasn't just memorized.
Right, and this is where the highest compute tier, GPT 5.2 Pro, really shines. It's asserting a claim of deep cognitive superiority. It scored 54.2% on ARC-AGI-2.
The thinking model.
The less expensive thinking model wasn't far behind at 52.9%. But when you look at the comparative data, I mean, Gemini 3 Deepthink scored 45.1%, and Claude Opus 4.5 was at 37.6%. The gap is significant.
So, the strategic read. Why is that gap so important to the enterprise listener? Why should they care about that percentage?
Because that metric indicates the model's ability to handle novel, abstract problems, not just variations of problems it saw in the training data. A higher percentage suggests a better ability to generalize and solve problems outside the training distribution, which is, the exact definition of innovation.
Right.
This metric signals the potential for rapid acceleration in R&D contexts, patent generation, and specialized high-margin consulting work. The sources even mention that the Pro model was used by internal researchers to explore a previously open question in statistical learning theory.
And it proposed a proof.
It proposed a proof that was then subsequently verified by external mathematicians.
So that moves it from just being a predictive text engine to a genuine scientific collaborator.
Exactly. But there's a ceiling we need to acknowledge here. In the realm of high-level scientific reasoning, the GPQA Diamond benchmark, this is PhD-level questions across physics, chemistry, and biology. It shows a different trend.
Okay, what did 5.2 achieve on GPQA Diamond?
GPT 5.2 Pro achieved 93.2%.
Which is very high.
It is, but it places it in essential parity with Gemini 3 Deepthink, which holds the top score at 93.8%. This tight clustering on such a challenging, high-level benchmark it's highly revealing about the current state of generalized AI.
Let's call this the competitive pivot point. What does that essential parity imply for the future of the competitive race? I mean, if everyone is scoring 93%, where does the innovation go next?
It strongly suggests that generalized scientific reasoning among the flagship models is approaching a performance ceiling, at least based on current scaling laws and available public data.
They're all universally competent at PhD-level science.
Right. And because the general scores are so tightly packed, the competitive race is now forced to pivot toward deep domain-specific mastery. Instead of chasing a fractional point on the universal leaderboard, the focus has to shift to which model is better fine-tuned for, say, specific protein folding tasks, or analyzing satellite telemetry data, or predicting chemical reactions in niche industrial environments.
So the future is customization, not generalization.
I think so.
And as a stark reminder of the velocity we discussed, it's worth noting the strategic obsolescence of prior models. GPT-4o, which we all thought was a marvel just a year ago, scored only 70.1% on GPQA Diamond.
Just 70.1%.
So the operational gap between 70% and 93% efficiency renders the older model strategically obsolete for any high-value reasoning tasks.
Yeah.
That decay rate is just critical for planning.
Absolutely.
Okay, let's move to section 3. Performance is one thing, but if the models are fast and smart, but still unreliable, prone to those confidently incorrect assertions, the enterprise just cannot integrate them into mission-critical workflows.
Nope.
So we need to talk about reliability, multimodality, and context handling.
And reliability was a major internal focus for the Code Red release because enterprise integration, it just requires dependability. The biggest quantifiable improvement here is the reduction in factual errors or, hallucinations.
Okay, what's the number?
GPT 5.2 Thinking produces errors 30% less frequently compared to its predecessor, 5.1 Thinking, based on standardized internal query sets.
A 30% reduction in the hallucination rate is monumental for adoption. It's the difference between needing to assign a human reviewer to every single critical output and actually trusting the machine for the first pass.
It is the definition of dependability. This directly addresses the biggest barrier to integrating AI into high-stakes workflows like financial analysis, medical research, and critical decision support.
Yeah.
When you pair the mega agent's maximum reasoning effort with this lower error rate, the cost of human oversight needed to verify outputs drops significantly, and this is where the ROI figures we'll discuss later start to make sense.
Reliability also hinges on memory, right? Particularly when you're dealing with massive corporate documents, which is a common task for enterprise users. So how did GPT 5.2 handle long context and memory limitations?
It sets a new state-of-the-art in long context reasoning. Long context accuracy has historically been a real weakness. We've seen models often forget critical details buried deep within a document.
Oh, for sure.
GPT 5.2 achieved near-perfect accuracy on the 4-needle MRCR variant. That's the multi-round co-reference resolution benchmark out to a massive context window of 256K tokens.
Okay, let's make sure the listener understands the application here, the technical takeaway. What does a 256K token window with near-perfect accuracy enable in the real world for, say, a manufacturing or a consulting company.
It allows the model to process complexity in its entirety. So for a consulting firm, it means the model can ingest years of internal client reports, external market analysis, internal company memos, we're talking thousands of pages, and maintain coherence and accuracy throughout.
And then it can extract subtle, consistent risk factors or competitive advantages that a human would spend weeks compiling.
Exactly. Or for a manufacturing company, it means ingesting all the maintenance manuals, the sensor data logs, the schematics for an entire production line, and then accurately diagnosing a rare systemic issue across multiple components. It enables these complex multi-source workflows that were just impossible before.
That efficiency gain turning weeks of document review into minutes is truly transformative. Let's look at multimodality, specifically vision and spatial reasoning. That's critical for interpreting diagrams and dashboards.
The model is being positioned as the strongest vision model yet. The most measurable improvement was cutting error rates roughly in half on two critical enterprise tasks: chart reasoning, so interpreting bar graphs, pie charts, that kind of thing, and software interface understanding.
So identifying and labeling buttons, menus, fields in a screenshot.
Exactly.
I recall the source material had a really great technical detail about how it improved, focusing on spatial awareness rather than just object recognition.
That's the key technical step forward. GPT 5.2 has a demonstrably stronger grasp of how elements are positioned relative to each other within an image. They use the example of a motherboard bounding box test.
Yeah.
When given a low-quality, zoomed-in image of a complex piece of hardware, GPT 5.2 was vastly superior to 5.1 at identifying components, labeling them correctly, and crucially, placing bounding boxes that actually matched the true spatial arrangements.
So it wasn't just recognizing that a resistor was there, it was recognizing where that resistor was in the circuit relative to the capacitor, which is fundamental to interpreting schematic or visual data correctly.
Exactly. It shows a much better internal representation of complex geometry and relationships, and that's essential for medical imagery analysis, interpreting engineering drawings, or synthesizing data from dense business intelligence dashboards. It minimizes the risk of misinterpreting the physical structure of the data source.
Okay, and finally, let's return to tool calling. This is the ultimate test of that mega agent architecture. It has to prove its reliability in complex, multi-turn, multi-tool workflows.
For sure. And the benchmark here is SWE-bench Telecom. It's designed specifically to test the model's reliability in using tools across long, multi-turn tasks that simulate real-world customer service interactions, things requiring access to multiple internal systems.
And the score.
GPT 5.2 achieved a new state-of-the-art of 98.7%.
The sources give a perfect and yet very stressful end-to-end example of a complex customer service scenario. Can you walk us through that, highlighting the difference between 5.1 and 5.2?
Yes. The scenario involved a traveler with a series of intertwined high-stakes issues: a delayed flight, a missed connection, the subsequent need for overnight stay compensation, and a critical medical seat request.
Wow.
This requires coordination across the booking system, the compensation system, and the special assistance system.
So that's 3 different systems and 4 interwoven tasks.
Precisely. And GPT 5.2, leveraging its unified mega-agent architecture, successfully managed the entire multi-step workflow. It executed the rebooking, it ensured the special assistant seating was confirmed with the airline's tool, it calculated the overnight stay costs, and processed the compensation claim accurately.
And 5.1.
Crucially, the same test run on the previous generation, GPT 5.1, fell apart midway. It typically handled the rebooking and maybe the compensation, but it failed to coordinate the specialized medical seating request, or it just got the multi-step calculation wrong.
That shift from a partial result to full resolution is the difference between an interesting internal prototype and a fully operational autonomous agent that a telecom or an airline can actually deploy to millions of customers.
It is. The ability to coordinate complex tasks reliably is the true hallmark of the mega agent's success. It means the entire chain of thought, even when it's relying on external execution, is just more robust against internal failure. And that's a massive leap for agentic applications.
That brings us seamlessly into our final section, shifting entirely from technical specifications to economic reality. For C-suite executives and CTOs, the question is always, how does this new intelligence, achieved through a code-red acceleration, translate into measurable economic value?
And OpenAI is pushing a proprietary strategic metric to answer that. It's known as GDPval.
GDPval.
This benchmark is explicitly designed to measure performance on well-specified knowledge work tasks across 44 specific occupations. We're talking everything from financial auditing and legal discovery to technical consulting and manufacturing workflow optimization.
This sounds less like an academic benchmark and more like a direct sales tool aimed at quantifying human labor replacement.
That is the strategic intent, no collision. By creating this metric, they're providing a direct economic justification for adoption that speaks the language of the CFO.
So what's the core claim?
The core claim is that GPT 5.2 thinking beats or ties industry professionals on 70.9% of the comparisons in GDPval.
And let's talk about the efficiency multipliers. Because competing against human labor isn't just about accuracy, it's about speed and cost.
And the efficiency multipliers are the truly compelling numbers for the C-suite. The model executes these complex knowledge work tasks at 11 times the speed of human professionals.
11 times.
And at less than 1% of the cost of human labor. These are tasks like creating complex financial presentations, performing regulatory compliance audits, and generating scenario-based accounting spreadsheets.
So why the CTO cares? This GDPval metric isn't just a number. It's positioning AI directly as an automated workforce. How does this change the competitive conversation?
It completely reframes it. The competitive conversation is no longer which model is slightly smarter, but rather which model offers better labor replacement potential and verifiable ROI. The fact that 5.2 performs at or above human expert level in nearly 3/4 of these knowledge tasks confirms that the current phase of high-stakes AI competition is intrinsically linked to productivity metrics and automation potential, not just abstract reasoning.
They are explicitly linking their performance to organizational gross domestic product.
They are.
But implementing this new workforce, it's not a one-size-fits-all API call, which brings us to a crucial point for developers. This layered product segmentation. The massive performance improvements we've just discussed are not available on the cheapest API path.
You've hit on the major technical complexity facing integrating enterprises. The 5.2 release is segmented into 3 distinct tiers, plus the specialized model, and it's all designed to force the enterprise to carefully manage cost and latency trade-offs.
Okay, can you detail those 3 tiers again for us?
First, you have GPT 5.2 Instant. This is your fast, capable workhorse. It's optimized for speed and low cost, ideal for high-volume customer service or initial data triage, where a fast, 90% accurate answer is better than a slow, perfect one.
Right.
Then you move up to GPT 5.2 Thinking. This is the core advanced reasoning model. This is the one that boasts the 30% fewer errors and is suitable for detailed research and multi-step planning.
At the top tier.
Finally, GPT 5.2 Pro. This utilizes maximum compute for the highest accuracy and reliability. It's intended for mission-critical tasks like code generation, deep scientific modeling, or complex legal synthesis.
And the dedicated coding model is still there, the GPT-5 codex?
Correct. Optimized for agentic coding and CLI use. But the challenge for CTOs is navigating this reasoning default shift. In the API, the model defaults to a none or low reasoning setting.
For maximal speed and lowest computational cost.
Exactly. And that path gives you the instant performance.
But the competitive wins we just spent 10 minutes discussing, the 100% AIME score, the 80% SWE-bench score, the 93% GPQA score, all of that is locked behind those higher compute thinking or pro mode.
Absolutely. And those premium modes, they necessitate higher latency and significantly increased usage cost. The model takes longer to execute its thinking processes because it's executing more internal passes, more self-critique loops, deeper searches within its parameter space. They even introduced a new maximum reasoning level called X, available only for the pro and thinking variants.
Can you give us an operational difference between thinking and pro? Like, how does that internal execution actually differ?
So the pro tier effectively allows the model to perform a much greater depth of internal self-correction and validation. Imagine the thinking mode allows for, say, 1 or 2 internal critique passes a quick check of its own work. The pro mode, especially when you're leveraging that X high reasoning level, might run 3, 4, or even 5 sequential critique passes. It's effectively increasing the computational effort by an order of magnitude, but it's also driving the accuracy from maybe 97% to 99% on highly complex tasks.
And this means the latency difference between an instant call and a pro call can be measured in full seconds, not milliseconds.
Oh, easily.
Which places a significant burden on the developer. Enterprise success now requires highly sophisticated task routing logic. You cannot just use the pro model for everything.
You simply can't afford it in both time and money. Enterprise success depends on minimizing the usage of that high-cost, high-latency reasoning path. Developers have to build systems that analyze the criticality of the prompt.
So if the task is summarizing a non-critical internal email, use instant.
Right. But if it is validating a key clause in a multi-million-dollar contract, the cost of failure justifies the expense and latency of the Pro model. The development challenge has really shifted from what the model can do to how intelligently you decide to use its various compute paths.
Let's put some numbers on that cost complexity by comparing API pricing.
It's a tight, nuanced race. The core GPT-5.2 model, so using the instant and thinking tiers, is priced at 1.75 cents per 1 million input tokens and 14,000 per $1 million output tokens.
Okay, and Gemini 3.
Gemini 3 is slightly different. It's 2 per $1 million input and 12 per $1 million output.
So 5.2 is generally a little higher on output cost, which is usually the most expensive part of a generation task.
Correct. And the Pro tier is significantly higher. It runs 21 for 1 million input tokens and a whopping 168 faces for 1 million output tokens.
Wow.
That really reinforces the need for smart routing. However, OpenAI has an argument here. They argue that even if the raw cost per token is higher than 5.1, the cost of achieving a given level of quality is actually less expensive.
Because of the new model's greater token efficiency.
Exactly.
That efficiency argument is key. If the previous 5.1 model needed 3 different complex prompts and 10,000 tokens of self-correction to get the correct, reliable answer, and the new 5.2 Pro model gets the perfect answer in one short, coherent turn for 3,000 tokens, the total cost of the job is lower, even with a higher per token price.
That is the economic defense. But we also have to discuss the elephant in the room here. The infrastructure instability and vendor risk that's inherent in this rapid iteration. We mentioned that 3-month deprecation window for GPT 5.1.
Yeah, but aren't hyper-iterative updates what we want in such a fast field? Isn't the friction of migration just the unavoidable cost of staying on the absolute cutting edge?
It's a classic trade-off, and that's a fair critique. While developers praise the capability, the infrastructure reality is brutal. This rapid velocity imposes significant API migration overhead. If you're running a mission-critical application, say a regulatory compliance agent on a specific version of 5.1, having to revalidate, retune, and redeploy that application every few weeks or months,
It introduces massive engineering risk and vendor lock-in.
it does. It forces enterprises to build an internal abstraction layer, essentially a buffer, to shield their production applications from the vendor's hyper-iterative development velocity.
So they don't break every time there's a minor update.
Exactly. Otherwise, they risk their production environment becoming functionally obsolete or crashing entirely due to unexpected API changes before their next quarterly budget review even happens.
And the alternative is selecting vendors with slower, more stable release schedules. But that means knowingly accepting a potentially lower state-of-the-art capability.
And potentially losing that competitive edge that GDPval is trying to quantify. It's a constant high-stakes calculation between velocity and stability.
Okay, that was a truly deep dive into the technical core, the performance results, and the economic framework of this accelerated Code Red release.
To summarize the technical driver here, the successful competitive counterpunch that led to the GPT 5.2 release was really powered by that architectural unification, that move into a single, powerfully efficient mega agent, which simplified all the internal orchestration.
And that foundational shift delivered quantifiable competitive advantages across all the critical metrics. It reasserted supremacy in intrinsic reasoning with a perfect 100% on AIME 2025 without tools. It pushed autonomous coding reliability to new heights with 80% on SWE-bench Verified, and it dramatically boosted enterprise dependability, cutting hallucinations by 30%.
The sources confirm this was a necessary and successful Code Red competitive counterpunch. It neutralized the immediate threat from Gemini 3 and reestablished OpenAI's position as the market leader in several critical metrics essential for professional knowledge work and autonomous agent deployment.
So our final provocative thought for you, the learner, to take away from this deep dive, focuses intensely on the velocity of obsolescence. This Code Red acceleration shows that competitive advantage in AI is now measured in weekly iterations, not quarterly releases. So consider the functional strategic gap. The flagship model from just over a year ago, GPT-4.0, lags severely at 70.1% on the high-value GPQA Diamond benchmark, while 5.2 sits at 93.2%.
A huge gap.
If a 23-point performance gap renders the old model strategically obsolete, how quickly must your development teams budget, plan, and deploy for the inevitable imminent competitive response, be it GPT 5.3 or Gemini 4, before your current, highly invested-in system is functionally outdated? The stability of your architecture is no longer a planning decision. It is a matter of weekly competitive pressure.
It's a constant race to stay relevant, and the window for catching up is shrinking exponentially.
That's it for this week's deep dive. We appreciate you joining us for this technical analysis of GPT 5.2. To stay updated on the latest in AI and ML, visit our webpage, neuralintel.org, and check us out on YouTube. Until next time, keep digging.